Okay, ladies and gentlemen, I think we have to start, regardless of the fact that there is a small number of us in here. It seems that organizing a gala event has an impact on the sessions after the gala event, morning after. So aside of killer sessions after the lunch, we have killer sessions after the gala events.
Okay, well,
I'm sorry for that. So this is the last session, session number 8. It's titled Information Exchange. As we all know, Internet is there because we use it for fast and efficient communication. And this session is going to present some ideas and also some interesting example of improvements in information exchange and knowledge sharing via the Internet, and especially in the scientific community. Let me start with our first speaker, Mr. Radovan Vrana from University of Zagreb, who will share his thoughts about advantages and disadvantages of current reference and digital object linking models. So, Mr. Vrana, please.
Thank you very much. Good morning to all who managed to come here today. As Mr. Milinovic said, evening gala had some repercussions. The inspiration or incentive for this talk came from the real-life situation I'm having. That is that the problem of accessing scientific information on the Internet is still an issue which requires special attention. So it's not easy to get the information you need. You have the infrastructure, you have resources on the other side, but in between there are some problems, and usually the problems are the most visible on the user side. The first point I'd like to make is that almost 90% of articles dealing with scientific communication is beginning with this sentence, that the number of information is growing rapidly. Of course, this is nothing new, and as we could see in the first presentation in the opening plenary, there are billions of websites and pages in so-called deep web space. But as far as scientific communication and scientific publications are considered, almost 50% of the information that can be found in references are almost impossible to access on the Internet. I think that the 50% is a very modest estimation, since there is so many articles, so many copies of articles, either on paper, which contain URLs, or in electronic form, so the problem still persists. And what is goal of current efforts of librarians and information scientists is to build some kind of a global instrument. First, of course, national instrument and the global instrument for access to scientific information in the easiest possible manner. The phenomenon which is linked or related to this problem is the deconstruction of information resources, which appeared in the 1990s. Deconstruction means that the usual article or usual book that you used to read and used to use in your scientific work is now deconstructed into smaller information chunks. As the number of information on the Internet, scientific information grows, the difficulty of reading a lot of information, a lot of articles is there, and you are bound to start reading only chunks of information and use that information in your scientific work. So the building or development of research often is depending on chunks of information, small parts, small information objects in digital form, which you are integrating in your scientific work, at least when you're doing the literature review. If you're doing the applied research, of course, you have to consider some previous achievements of the previous scientists and their works, and this development of a learned article then becomes kind of systematic publication of fragments of previously published knowledge, or you can call it a patchwork of a kind. The scientists in this fashion, the scientists are becoming some kind of integrators of fragmented work. And as you can probably imagine, the more electronic articles and electronic journals will appear on the internet, the more references there will be, and the more the patchwork will spread. There are some basic notions or basic ideas of what is required, or what are the basic requirements on the side of the reader. The reader, as researched by Clifford Lynch, one of the famous scientists that wrote a lot about scientific communication, can be summed up in 3 points. The first one is references. These are readers' requirements. So the readers are requiring that there must be some mechanism for reference linking references, which we know from the printed resources. So the well-known references at the end of each scientific work are still viable, are still working, and still good. And the second part is, of course, linking. The linking part is the hardest one. I'm going to devote some time to this problem in the later part of the presentation, because linking is connected with infrastructure. Linking is connected with organization of information resources, of the internet, of people, and many other factors that sometimes cannot be controlled. And at the end, as a third requirement, there is an archiving function which can function in case of scientific communication in the sense that everything that is published in scientific journals can be archived. Other content, like information on the internet or personal web pages, cannot be archived so well or cannot be archived at all. So let's focus just on the scientific articles and journals. And some kind of imaginative or real goal to this is the global interlinked virtual library, as said by Harned. Well, we'll see if this is possible today. Just one slide about the past information systems. So what we know about past information systems is that the basic idea behind those systems is that everything is stored locally. So if you had a reference in your work which you could follow and come to the actual information object or article that is referenced in previous work, you have to deal with the local databases. The problem with the local databases are that they are local. So everything is pretty restricted. So there is no option of going to the outside source except for the librarian who is willing to help you and try to dig out some other information sources. Of course, the advantage is that everything that is stored in a local database is available to you. The local infrastructure is working for you, and there's nothing very problematic here except for the well-known issue of changing local addresses in local repositories of information, which can be tedious job and can end in inability to access information resources. This advantage is actually pointing to the URLs. If you have something that is locally stored, that is just pointing, that uses URL as a pointer, there is a danger that the slightest change in location in your database will be fatal to your user, which is trying to access the information. So the URL are no good, as you all know, because of the changing environment in which they are becoming useless. The second type of URLs are persistent URLs, which are trying to solve the problem of the changing environment. They are pointing to several addresses, if needed, by the help of a special service which is called the resolver. The resolver is similar as the DNS and function as a middleware from user to the end information resource. The resolver holds the address of the real location of the information object, digital information object, and it helps user to access that information. The resolver also has another special function. It can hold up your local rights, local permissions to access some information object and deal with you in such a way that it can or cannot pass you through to the information resources. There is a problem of so-called the appropriate copy of the work you are trying to access. I will address this a bit later in my presentation. The basic idea can be presented by this schema. At the top you see the starting URL, which is saying I need it urgently document, and I need it bad. So if you are trying to access it by use of standard URL, you are bound to 50-50 chance or even less that you will be able to access it. So if you have some kind of a resolver that takes care of the changes that can occur in electronic environment on the internet in case of any change, that can redirect you to second or third location where the digitally stored or digitally formatted information is waiting for you. This is great. The resolver itself can be stored at library or some other institution, and as the persistent URLs are trying to be more visible on the internet, they are trying to also to allow people to maintaining themselves. So you can register as a maintainer of this of your part of the resolver and maintain your links towards the information resources. Of course, you have to take into consideration that this is a full-time job sometimes, trying to manage on one side your regular job, on the other your information resources. The next one is one of the newest initiatives. It's the Open URL. It's called Open because it's an open initiative, and it is expected that the people will contribute actively to this initiative. When compared to the persistent URLs, it adds something more. It adds the context-sensitive linking environment in which, again, there is a resolver, as you will see on one of the next slides. And this Open URL is a bit longer than the usual URL, and it can contain metadata about the information object itself. So if you have the standard URL with the address, with the name of directories on the remote location and the name of the document itself, the Open URL usually holds much information about the author, about the article, about the journal in which you can find information and possible other metadata. These metadata are encoded in URL in the usual fashion. It's the URL encoded, and there is no other problem than just relaying that information to the resolver, which will then point you towards the end location. There are two basic parts of the Open URL. The first one is the base URL, which is containing the address of the resolver. So this is the usual internet host address, and the second part is the part containing the metadata. There are two parts of it. The one is the query, which contains the attributes, and the description contains the metadata or values of the attributes, which is OpenURL holding. So this is the demo of this OpenURL, which can be accessed on the internet freely, and you can try it and see whether or not it works for you. So the first one, or the base URL, is at the top, and this part is well known to all users of the internet. The second part is containing additional information from here, which is metadata about the article ID, the digital object identifier, which is now spreading as an effort or initiative to uniquely identify each article on the internet. And this is the date of an issue, this is the title, this is URL encoded, so you'll have lots of percentage signs and space signs and so on, escape sequences. So the trends in the evolution of the public library web, or public web. And there you have the title of the magazine, which is the daily magazine, the ISSN number, the date, and volume, issue, and the last and the first name of the author. So anything that can be imagined can be added. Of course, this is very long, so we'll see another solution, which is probably a bit better. But the OpenURL is it's very good. It's now trying to be accredited for standards, so it's well accepted. This is a bigger diagram or scheme of this URL concept. First, there is a user, you and me, trying to get the information which is stored far away or locally. To be more efficient, this user query can be dealt with locally. So try to use the local databases, secondary or even tertiary information resources to see whether or not there is some local resolution or solution to this problem of query, and redirect the user or just present him the primary document immediately. If not, or if this is not possible in the local environment, the query is forwarded to a resolver which is holding the information about the location or several locations of the information you need. So the resolver is resolving your access issues, your rights to access some information, whether or not you have a subscription to a journal, whether or not you are entitled to one or the other version of the article, and so on. This all can be happening on local or remote environments. So the resolver can be in your institution or can be elsewhere. At the end, if it's not possible to redirect you to a local source, then you are located or redirected to additional resources on the internet, which can be portal, electronic journals, or something that is called document delivery. When speaking about document delivery, a week ago there was an article in the Digital Libraries magazine, which appeared a week ago. It holds or presents the latest information about the behavior of scientists in the last 12 years in the United States. It shows that the amount of the percentage of the surveyed scientists in the United States using this document delivery, so just the separate articles or separate scientific works from some publication, is growing rapidly. In 1990 it was 13.1%, and last year it was 35.8%, while other personal subscriptions are going down, and library subscriptions are slightly going up. So the people are using this trend of deconstruction of information resources taking just chunks of informations which are needed, and then use the document delivery mechanism to get it from a resource. All this is happening in the user context, so it should take into consideration user needs, user preferences, use user profiles when available, or let the user has its own role, which is then decided by resolver. Yeah. Of course, there is, again, problem of appropriate copy, which is a separate problem. So this system should take into consideration what you know about the source, what you are entitled to, what you are able to pay, what are your previous experiences or searches, and so on and so on. So this is the finding information plus its location depending on user contents, electronic resources subscription, document delivery systems that can deliver the actual information to you at the end of your search. So if you have user profiles in the middle, which is saying that you are entitled to information on some other remote location, and there is absolutely no mechanism to deliver this information to you, this is a problem. So the whole infrastructure or the whole scheme on the previous slide must be functioning pretty well, and all sides included should be prepared to support such mechanism. Of course, there are some advantages to this mechanism. So the advantages are that it is taking into consideration user context. It offers multiple document location, follows standard URL syntax, and now is accredited for a standard, at least in the United States. We will see what will happen in wider environment. The disadvantages are that it's still not widely accepted. So it's in the process of standardization, and perhaps after that it will be possible to apply it. It's still complex to implement because of the previous slide. You see how many links, how many parts of this mechanism are there. And of course, there is the obvious question, who will take care of the resolver, which is essential in this concept. Will there be libraries to do that? Will there be users? Will there be special agencies? And the last example is something that is one of the initiatives that is going on parallel to the Open URL initiative. This is the Crossref. The Crossref is using the digital object identifier, this DOI, which is the unique identifier for each article in electronic journal. The initiative started on the side of the publisher, who are trying to offer their users, to attract more users. They are offering their services of identification of electronic journals, of articles in electronic journals, and by single click on the DOI, which is much, much shorter, it contains only alphanumeric identification, which is much, much shorter than the Open URL and standard URL. It can lead you to an article itself. The DOI is related to publishers, not the user, not the libraries, so all the costs goes to publishers. Of course, there's a danger that publishers, as usual, are trying to get more control in the new environment, and this is the big issue that is yet to be resolved. The DOI server offers centralized approach, which can be, again, very problematic, that somebody is holding information about the location of information chunks or information digital object, which is not good. Shorter than the Open URL, less possibility for mistakes, for typos, misspelling, and so on, and again, errors in syntax, and follows the standard URL syntax, which is still available today. I'm talking that because all solutions presented in these presentation are following all we know, so all the possible standards and uses that we use every day, so the HTTP protocol, the URL syntax, and so on. And of course, there is the main part is that the Crossref can hold DOI, the digital object identifier, which is then seen by user at the end of some article, at the end of a part of the references, or at least, for instance, there are 10 references at the end of some electronic article, and 5 of them have DOIs at the end, stating first the name of the author, the title, the publication, and at the end, DOI. So the user is looking at the citation, clicking on DOI, DOI is transferred to the DOI server. The server is resolving issues of access and authentication to the resources, and of course the end is at publisher's website. All this should be seamless, or user should not be making too much effort into what is happening beneath this mechanism. DOI can be also part of the open URL. So this huge URL, which open URL is presented, can contain a DOI, and then again, so you can be redirected instead to an open URL resolver to the DOI server, which then again can point you to another resolver which holds your rights to access the information, and find for you the appropriate copy according to your rights to access information resource. And before the very end, there is, I'd like to say a few words about Croatian situation. My colleague will talk about it after me. So there is something called Croatian scientific bibliography. The bibliography itself is a database which holds information about scientific bibliography in Croatia, and it holds the local copy of information object if user decides to upload it. So the biggest problem from my side, from user side, is that I cannot find articles themselves on even books if the user is not willing to, or is not able, because of the restrictions, to upload it. So there is the problem of voluntary upload of metadata and documents themselves, and there is no segmentation of articles. So you cannot pull out part of the article that you are in need of, or just look at the article itself from another location. Just you have to go to the database itself, try to find it by search engine, and then look at one of the formats of the documents in the database and decide whether or not you can read them. This is very difficult. Unfortunately, there is no place for URLs. I'm cheating on this database. For instance, for the last year Carnet Users Conference, since it is on CD, there are no pages. So my article is on the CD, and instead of pages in the database, I put the URL to the Carnet's website where this article of mine can be found. This is cheating, but I'm trying to fool the system. At the end, I'd like to say that there are much more to be done. There is a lot of space for the enhancements of this system. This system is one that we can call the early systems, because it's holding the information only locally. So you cannot access my article if you are trying to find it from the OPAC of Online Public Access Catalog or Webpack in the National Library, where it can say that I wrote this article for the last year's conference, but there is no pointer to the document itself or to the Croatian scientific bibliography. So at the moment, we are lacking this interconnecting between the metadata, the library catalogs, and the objects themselves. However, if you have document stored, there is a good starting point that you can enhance your service and offer your user a document that is needed, either from the library webpack, Web Public Access Catalog, either from the database interface itself, or from the third location by using some of the mechanism I try to present in these slides. And to conclude, the difficulty of finding scientific information is there. The difficulty is that you can accidentally find information that you are badly in need of, and if you try 2 or 3 days to find it, you can end up with empty hands. So if we agree upon a mid-level or middleware service which can be a resolver, so there can be a mechanism that you can rely on that will be holding for you all the information about the location of scientific works that are relevant to today's science. All these mechanisms are using the standard internet or internet standards, so there is nothing new that you can add, or you can only enhance your link bandwidth. But the problem with libraries are that they are coping with standard issues about webpacks, databases. They are in struggle with online aggregators or information vendors with paying licenses, and they usually do not have any time or money to deal with new solutions, technical solutions. However, I think that such mechanisms are very valuable in the long run, and that they will enable us to access the information in the shortest possible way. That's it.
Thank you, Mr. Vrana. While we are waiting for the next speaker to prepare, we have time for one question, short one, if somebody has. Fine. Thank you again. We now will have our second speaker, Jadranka Stojanovski, from who is the head of the library at Ruđer Bošković Institute in Zagreb. And this talk will be some kind of add-on the one of the previous slides seen. It is a talk on Croatian scientific bibliography system that actually is considered to be a tool for monitoring scientific productivity. So, whenever you are capable of, Ms. Stojanovski, you can start.